In this video, I want to have a look at solving trig equations that involve sine and cos. So our first example asks us to solve the root 3 sine x minus cos x equals 1 between 0 and 2 pi. Now there's two main methods for solving these. One is using the t results, or the other one is when we rewrite it into the form r sine x minus alpha. Now, both of them work. It's up to you which way you use. We're going to run through both of them and show you that you get the same solution and so that you can compare them. So since we've already written that, let's call this method 1. And this is also known as what's called the auxiliary angle. So we're going to rewrite the left-hand side of this equation into this form. So that means we're going to have root 3 sine x minus cos x is equal to r sine, now I'm going to expand this out, so let's write r sine x cos alpha minus cos x sine alpha. So that means the coefficients, if we equate them, we're going to have root 3 is equal to r cos alpha. Root 3 equals r cos alpha, and 1 is equal to r sine alpha. Now let's call those equations 1 and 2. Now if we do 1 squared plus 2 squared, that's going to give us 3 plus 1, if we square that and add them together, is equal to r squared cos squared alpha plus r squared sine squared alpha. And we know that cos squared plus sine squared is 1, so if we factorize out r squared, we'd have r squared outside of cos squared plus sine squared, which will just leave us with r squared equals 4. Which means that r is equal to 2 because we only take the positive case. Now if we sub that into 1, or 2, doesn't matter which one, we'd have root 3 equals 2 cos alpha. So that means that we'd have cos alpha equals root 3 on 2, which would end up giving us alpha equals pi on 6. All right, so using those, we can rewrite this equation was in our original question. We can rewrite that as 2 sine x minus pi on 6 is equal to 1. So that's using our r and our alpha that we've just found. Now we know how to solve this. So we're going to start off by saying let theta equal x minus pi on 6. And that's going to change our equation to 2 sine theta equals 1. But it's also going to change our domain. So for our domain, we'd have to subtract pi on 6 from our lower and our upper bounds. So our domain would become minus pi on 6 is less than or equal to theta is less than or equal to 11 pi on 6. If we rearrange this, we're going to have sine theta equals a half. And from our all stations to central diagram, we know it's in the first and the second quadrant because it's positive. And we know that our related angle is going to be pi on 6. So that's going to give us theta equals pi on 6 or 5 pi on 6. But that's theta and we want x. So we know that to get to x, we're going to have to add pi on 6 to both of those. So this would give us 2 pi on 6, which would just be pi on 3. And this would give us 6 pi on 6, which would just give us pi. So we've got two solutions in that domain for this equation. Now that's the first method. Let's have a look at the second method, which involves using our t results. So if we're going to use our t results, then the first thing we're going to do is let t equal tan of x on 2. Now we're going to rewrite our sine x and sine x and cos x in terms of t. Now there's one problem, or not really a problem, it's just something we have to be aware of when we're solving equations using t results. And that is that we know that tan of x on 2 is not defined at pi or 3 pi or 5 pi. It's not defined there because we know that tan has asymptotes. So if it's not defined at pi, then we're going to have to solve it using t results, but then we also have to specifically test whether x equals pi is a solution to that equation. So there's just one little extra step at the end if we're using t results. So let's go through and see what it looks like. So we know that we're going to have root 3. We know that sine x can be rewritten as 2t over 1 plus t squared. And then we're going to have minus cos x, which is 1 minus t squared over 1 plus t squared. And we're going to have that is equal to 1. So now they have a common denominator. So let's go through and multiply everything by 1 plus t squared. So we're going to have 2 root 3t minus 1 plus t squared, so that's expanding out that negative there, is going to be equal to 1 plus t squared. Now if we bring all of that onto one side of the equals sign, when we subtract our t squared, they're going to cancel out. So we're going to have 2 root 3t minus 2 is equal to 0. Probably shouldn't have bothered bringing that to over. I should put that over the other side. So we'd have 2 root 3t equals 2. So t is equal to 2 over 2 root 3, or just 1 on root 3. Whoops, that's not a very straight line. So what that means is that tan of x on 2 is equal to 1 on root 3. Now we want to solve this equation in this domain. So first off, we can let theta equal x on 2. So then we've got tan theta equals 1 on root 3. But again, that's going to change our domain. So instead of going between 0 and 2 pi now, because we've divided x by 2, we're going to be looking at theta just between 0 and pi instead. Looking at our all stations to central diagram, tan is positive. So that's here. It would be down here as well, except we don't want to go past pi, which is here. So we're only looking at this one. And we know that our related angle is pi on 6. So that means our x on 2 is pi on 6, which means that x would be double that. So that would be x is equal to pi on 3. Now that's one solution. Like we said though, we do have to test whether x equals pi is a solution as well. So I'm just going to rub part of this out so I've got some more space. So I'm going to test x equals pi on, oh sorry, not x equals pi on anything, just x equals pi. So if I put that into the left-hand side, I'm going to have root 3 sine pi minus cos pi. We know if you look at your graph of sine, that sine of pi is 0. So we'd have root 3 times 0. And if we look at the graph of cos, we know that cos of pi is minus 1. So we'd have minus 1. So that's just going to give us an answer of 1, which is what we wanted. So therefore, pi is also a solution. So we've got pi on 3 and pi, which is exactly the same answers we got doing it the first method using the auxiliary angle. So 2 ways of doing it to get the same solution.